Assalamualaikum. We want to present about our project assignment for subject design optimization. Our member group is Azide, Fahmi, Karar, and me, Ariffuddin. For the introduction, topology optimization is the process of determining the best form of design with the finite element computational approach. The goal of this process is to increase the stiffness while minimizing the weight. This also possible attempting to maintain maximal stress below a specific level. For the component, we choose bell crank for our project. This component is a type of crank that rotates at an angle to change motion. For the earliest application, this component is used to ringing or strike the bell, which was used to summon personnel in large accident. For today, this component has in aircraft, automotive, and etc. For the aircraft, bell crank usually utilized to connect the pilot's control to the control surface. For the automotive application, this component is part of linkage that connect throttle pedal to the carburetor and brake pedal to the master brake cylinder. For the software that we use for this project to simulate is ANSYS. ANSYS is the company that creates and sells engineering simulation software. ANSYS software is the simulate computer model of structure, electronics, or machine component to evaluate strength, toughness, elasticity, temperature distribution, and other characteristics. The advantage of the software are it has a wide range of functions. Second, it is innovative that allow for a great deal of customization. And lastly, the execution of quite complex simulation with relative ease. For the process, this is the general explanation of topology optimization process. First step is design the model using 3D computer-aided design. The second step is simulate using ANSYS topology optimization. After that, remodeling to touch up the design and verify the process. Lastly, get the final design and repeat the step to get how much the process that you want to remodeling. So I will pass this presentation to the Azide to continue.
Okay, next, I will present about the chapter 2 methodology. Before that, I will introduce myself first. My name is Azide bin Janghishan, with the matric number B0417100228. Next, I will continue about introduction of the methodology. This chapter describe of the methodology used in this project to design and optimize the bell crank. The flowchart of the project is shown in figure 2.1. From figure 2.1 we can see starting for the project we simulate the static stimulation of the product, and after that we do the topology optimization of the product. After that, after the topology, we redesign and make a simulation about it. After that, we 3D printing it in the 3D printing software, and lastly, we write the report and submit the report to our lecturer. Okay, next we talk the NCs. First, our team will be simulate the product and apply the material use, meshing, structure load, and the structural support in NCs. Next, we'll execute the topology optimization in the NCs. After that, product that has been topology optimization will be subsequent to be utilized to conduct another simulation. The deformation, stress, and the safety factor data of the original design and the optimization model will be compared. Okay, this is our picture that has been collected for our team in NCS. For the first left side picture is we import the model to the NCS and apply the material used to the product. And the second picture in the middle is we matching the product, and lastly we apply the structure load and the structure support to the product. Okay, next point, we talk about the topology optimization. The topology optimization model will be less weight and the volume than the initial model. The weight and the volume of the original model and the topology optimization model will be recorded in the table. You can see that we already make a table that will compare the initial model and the topology optimization model in weight and volume. Okay, the next step, we redesign our product. The topology optimization model design will be redesigned based on the topology optimization. The new design for each condition will be analyzed according to the condition applied. The data will be gathered as shown in the table below. So you can see from the table, we compare initial model and the topology optimization model and collect their data about the deformation, maximum stress, and safety factor for each condition that apply to in the topology optimization, such as a reduction weight condition from 20%, 40%, 50%, 60%, and 80%. Okay, next we talk about the printing software. 3D dimension 3D printing is the technique we use additive to create a physical object from the digital template. The technique works to fuse the tiny layer of the material in the form of liquid or the powder plastic, metal, and the cement. Our team utilized a repeater software to determine how long the printing duration of the original model will be, as well as the topology optimization model, and record it in the table. You can see our team has been made a table to compare a printing time of the initial model and the topology optimization model.
Assalamu alaikum everyone. My name is Karar Fadhil Abbas, FKM student. Now I will be talking about result and discussion. For our result, we focus on 5 things. The first thing is comparison of weight and volume between internal model and optimization model. As we can see here, we have reduced weight condition, which is 20%, 40%, 50%, 60%, and 80%. We have the internal modeling result, and we have the optology optimization modeling. As we can see here, this is our previous for the internal model, and this is our new data for the topology optimization model. So we reduce our weight until 20%, almost 20%. We go for the next. This is our graph for our design. As you can see, this one, the first one is for 20%, second one is for 30, third one for 40, for 20 and 40 and 50, 60 and 80. Second, we go for the comparison mesh. For the comparison between Intel model and optimization model, we have the reducing weight condition, and we have Intel modeling, and we have topology optimization model. As you can see, we have our number of nodes and we have our number of elements. So for the first four, which is 20, 40, 50, 60%, we are increasing our elements, but for number 80 we are reducing our elements. So now we go for the figures. Here we have our figure for our design. This one, the first one for the Intel model, then for 20 and 40 and 50 and 60 and 80%. We go for the computation of total deformation. So we have our reducing condition, and we have Intel model, and we have topology optimization model. So here we got our minimum 0 and we got our maximum, and as you can see we are reducing minimum and our maximum also. As you can see here in the figure, we have our design for the our design for the Intel model, and for 20% and for 80, for 20 and 40 and 50 and 60 and 80%. And we are focusing on the same durability and the same quality. Next we go for the comparison, the equivalent von Mises stress of modeling. Here is our result, and we go for our design part. Here for the Intel model, and for 20% and 40, 50 and 60 and 80. So we have the comparison in 3D printing. So here we got the reducing weight condition, and here we got our Intel model, which is for all types. Before our topology optimization was 57 hours 3 minutes per second, and after we do the topology optimization models, we reduce our time until we get less than half time. As you can see, the minimum we have is 23 hours 24 minutes and 39 seconds. Here is our design. As you can see, for 20, 40, 50 and 60 and 80. We go now for conclusion. The result of the topology optimization produced from the analysis is the objective that has been established, which is analysis the loading using computer editing design, produce topology optimization, and remodeling the internal model for 3D printing. Those 5 different conditions are set in this experiment. The first thing is weight and volume between Intel model and optional model. Second thing is mesh between Intel and optional model. The third thing is total deformation between Intel model and optimization model. The number 4 is equivalent Voss mass stress, and 5 is 3D printing time between Intel model and optimization model. Thank you. That's all for me.
So for chapter 3, design discussion, the parameter of the initial model that have been assigned consists of 19 kg with volume of 0.00415887. The topology optimization is analyzed and being done to reducing the weight of the model to the minimum while keeping the structural condition in the base level of strength and quality. So the table 6 show that the minimum reduced weight condition apply is 20% and the maximum is 80%. So for the comparison mesh, we can see at the table 7, the maximum number of nodes is at the reduced weight condition of 20%, which is 322,225 number of nodes. So for the comparison total deformation, we can see at the table 7, the topology optimization models creates a higher total deformation than the initial model when 80% of the weight is being removed. So for the comparison of the equivalent volumetric stress of models, we can see the topology optimization model creates highest volumetric stress better than the initial model when 80% of the weight is being removed. So for the comparison safety of factor, we can say the table 10, the topology optimization model creates same height of factor of safety with the initial models when 20% to 80% of the weight is being removed. Therefore, the result is proof that the component is safe to be used and has a high safety measurement and quality. So for the comparison in 3D printing time, the longest of 3D printing time is for design of the initial model and the shortest time is for the topology optimization model at 80% of the reduced weight condition. So for the conclusion, the result of the topology optimization produced from the analysis is to obtain the objective that has been established. So the 5 conditions are the percent of the reduced weight condition, which are 20%, 40%, 50%, 60% and 80% of the removable parts from the initial model. So for the best topology optimization compared to the initial model is the reduction weight condition of 80%, which is 4.64 of weight with total deformation of 7.43, equivalent volumetric stress of 2.83, safety factor of 15, and the fastest printing time. Therefore, the conclusion has been concluded that the purpose, which is to produce the topology optimization and the model, the initial model, is success with the using weight of reduction condition of 80% of the removable parts from the initial model. Thank you.